This lecture is an overview of industrial hygiene. I'm going to go through some basics on the field and introduce you to a little bit of some of the things that we're going to be doing throughout the semester. What I'm going to be covering is, first of all, an overview of industrial hygiene, which will consist of what is industrial hygiene, why do we have the field of industrial hygiene, what do industrial hygienists do, and finally, what are some recent developments in the field of industrial hygiene. Now, in this course, I do not ask you to memorize a lot of definitions, but there is one that I expect you to know, and there will be a couple more throughout the semester, but this one's important, and we already have the old exam ones posted on Blackboard, and if you will note, every one of those old exam ones has the question, define industrial hygiene. Well, here's the definition, and I'll just read it to you, and then we'll go through and talk about it in a little bit more detail throughout the course of this lecture. Industrial hygiene is that science or art devoted to the anticipation, recognition, evaluation, and control of those environmental factors or stresses arising in or from the workplace which may cause sickness, impaired health and well-being, or significant discomfort among workers or among citizens of the community. Now, that's a little bit of a mouthful, and a little later we'll talk about what is meant by anticipation, recognition, evaluation, and control, because these are the things that what an industrial hygienist actually spends a lot of their time doing. And in a minute we'll talk about some of the specific environmental factors or stresses which can cause problems in the workplace. But while we're still on this slide, there are a couple things that I want to point out about it. First of all, industrial hygiene is a science or an art, and that's an important component of the definition. You have to achieve a certain amount of scientific technical competence to be able to function as an industrial hygienist. But, however, what makes this field really kind of unique and somewhat fun is there's a lot of creativity or art involved in it as well. For example, if you're called upon to do air sampling, you're going to have to know the scientific technical basis behind air sampling. You're going to have to know what kind of contaminant it is you're sampling, what kind of filter you can collect it on, what the methodology the laboratory is going to use to analyze it. There's a certain amount of technical competence that goes into it. However, there's no cookbook on how to do air sampling from one facility to the next. Every facility is going to be somewhat different, and so you're going to have to apply the science in a creative way to try to solve the problem that you're facing. So there's a lot of creativity involved in the field of industrial hygiene, and it appeals to a lot of people because of that. They can take their scientific expertise and use it in a way that's creative and fun. The last thing that I wanted to point out about this particular slide is that industrial hygiene is a little bit different from safety. We don't deal with trauma. We deal more with things that are insidious or chronic problems that may cause sickness, impaired health, sometimes chronic conditions that may take decades to develop. We try to prevent. And recently, due to much of the emphasis on environmental protection, the American Industrial Hygiene Association has really tried to make its members realize that it's not just the workers you're protecting, but sometimes chemicals or problems can go outside of the fence line and affect the community, and that's part of what an industrial hygienist needs to be aware of as well. So let's talk about some of those specific environmental factors or stresses. And I have a list of 4 main categories. We'll be spending the course on 3 of those categories, and I want to just introduce you to what these are. First of all, you have chemical factors or stresses that could be problematic, physical, biological, and ergonomic. Now I want to go through each one of those. A chemical factor for industrial hygiene purposes is usually something that you inhale. There are other methods of being exposed to chemicals, but predominantly for an IH environment, we're dealing with an inhalation hazard. And this is going to be then gases, vapors, or aerosols, which are dust particles suspended in the air. And any of these, if you breathe them in, they can cause a potential health problem. And I have 3 listed down at the bottom. And what these 3 chemicals all have in common is that they're carcinogens, or chemicals that can cause cancer. And I have listed vinyl chloride, benzene, and chromium-6. Vinyl chloride is a monomer used in the production of polyvinyl chloride, or PVC, which is the piping that you'll see in a lot of modern-day plumbing. And as a monomer, it's a very volatile substance which can be inhaled, and it is a very potent carcinogen. It causes a really rare and unusual type of a liver cancer called an angiosarcoma. This was actually discovered in Kentucky back in the 1970s. It was one of the early OSHA regulations on protecting workers against vinyl chloride monomer. You breathe in the vinyl chloride, and it causes the liver cancer to occur, the angiosarcoma, by a mechanism that's pretty well understood now. And we'll talk about a little bit about that when we get into the toxicology section. The next chemical is benzene. Benzene also is a cancer-causing chemical or carcinogen, and it causes a type of blood cancer called leukemia. If any of you work for the petroleum industry in the future, this is going to be something you'll be measuring for and trying to control for, because benzene is a contaminant of most petroleum products. And inhalation of high levels of benzene over long periods of time has been shown to relate to many health effects, including the development of leukemia. The last chemical on the list, chromium-6, is a real interesting chemical in several ways. It is the most recent OSHA standard. OSHA has set a pace of about one chemical-specific standard every 4 or 5 years at this point, and the most recent one they came out with was the chromium-6 standard. You also might know this as the hexavalent chromium standard or hex-chrome standard. It's an aerosol. Unlike vinyl chloride and benzene, which are vapors, this is an aerosol. So it's a particulate matter suspended in the air, and if you breathe that in, it's associated with the development of lung cancer. Pretty interesting chemical, chromium-6, because chromium in the +3 oxidation state is actually an essential micronutrient. But if you're exposed to it in the +6 oxidation state, it's a carcinogen. But anyway, these are some examples of chemical hazards. The next class is physical hazards. And when I mention physical hazards, what I'm talking about are hazards such as noise, radiation, or extremes of temperature and pressure. And during this course, we will be, after the second exam, we'll be discussing noise and radiation and some ways of measuring both, and ways that they can cause harm and ways that you can control for them. So this is an important component of industrial hygiene. Extremes of temperature and pressure are as well. We will not be getting into that in this course much, except for the discussion of how to make corrections when you're dealing at different temperature and pressures from standard temperature and pressure. So we will talk a little bit about some corrective approaches that can be used in calculations. The next area is biological hazards, and this is a reasonably new area for industrial hygiene. It pretty much started in the late 1980s when OSHA, for the first time, promulgated the bloodborne pathogen standard. And the bloodborne pathogen standard was really the first time OSHA sort of got into the biological world a little bit, largely due to, at that time, the prevalence of hepatitis B and the emergence of the HIV virus. Subsequent to that, a lot of people with biological backgrounds have done a lot of work in the field of industrial hygiene, and the biological field has become much more important. In particular, in indoor air quality examinations or investigations or remediations, where sometimes mold will be a problem. And mold is a biological entity. If you are an expert in mold, you study the field of mycology. It tells you how molds grow, how they put out their spores, and how you can control for them. And so it's a real specialized area for industrial hygiene for people that have quite a bit of knowledge in biology. The bloodborne pathogen standard dealt with a lot of how to handle medical waste and products from people, blood, spit, etc. And that's considered to be a biological hazard. And bioterrorism agents are something we'll be talking about later on in the semester. That after 9/11, the Center for Disease Control came up with a list of bioterrorism agents that could be used against the civilian population. And if you have any of these agents that are released, someone has to identify and measure them. And one of the frontline defenses are people trained in the skills of industrial hygiene that can go out and determine whether or not this white powder is anthrax or whether it's powdered sugar off a donut. Industrial hygiene has the tools to train people how to do that. And the annual conference every year has a section on dealing with bioterrorism agents and measuring these in the field. So it's become a very important area in the field of industrial hygiene. The last is ergonomic, and we don't cover ergonomics in this particular course due to time constraints, but we do have several courses in the curriculum dealing specifically with ergonomics, and some of the problems that can lead with ergonomic issues are cumulative trauma disorders or lower back strain. The next topic that I wanted to mention a little bit on is if you go to the American Industrial Hygiene Conference or even look at their membership list, and I think there's about 15,000 people that are members, maybe 10 to 12,000 go to the annual meeting every year. If you ask people, what's your degree in? And pretty much everyone that's a professional member has at least a bachelor's degree. You ask them, what's your degree in? You'll get a lot of different responses, very few of which will be industrial hygiene. Because even though you can get a specific degree in industrial hygiene, it's very much a cross-disciplinary field. You'll find a lot of people who are practicing in industrial hygiene that bring in a lot of different backgrounds to the field. For example, if you have a background in the basic sciences like chemistry or biology, you can work as an industrial hygienist. A lot of what industrial hygienists may be doing are monitoring for chemical exposures in the workplace, and to do that you have to understand chemistry. You have to understand how to monitor for chemicals. You have to understand how to detect chemicals, some of the analytical methodologies. So chemistry is a really important aspect to industrial hygiene. I just mentioned biological hazards, and if you have a degree in biology, you're going to be very much ahead of the curve in dealing with people on studying some of the biological problems. Another area is toxicology or medicine. If you understand the effects of chemicals on people and some of the diseases that they can cause, the background in toxicology or in occupational medicine can be very beneficial. Then math and statistics. A lot of industrial hygienists now do not even do any monitoring. They just do modeling. And to do modeling of exposures requires a very thorough knowledge of mathematics to set up the type of modeling that is done to generate exposure models. And so a lot of math and statistics go into the derivation of these models, and it's becoming an increasingly important field, especially when you're dealing with historical exposures that may occur, or if you're designing something and you want to know what maximum exposures could be. Running the mathematical models can be very, very beneficial and save a lot of time from the actual industrial hygiene monitoring. Then I have physics and engineering. Physics is another basic science like chemistry and biology, and when you do physical agents, noise, radiation, etc., if you have a degree in physics or an understanding of physics, that can be extremely beneficial. If you have a noise abatement project, the people who are probably most qualified to address that are people with backgrounds in physics or acoustical engineering that may be able to design different types of acoustical tiles that will abate the noise so that you can solve the problem. So you have all of these scientific disciplines that are mentioned here that play an important component in industrial hygiene. And the last is communication. And I want to mention this in a couple of different ways. First of all, this is a field where you're going to have to communicate a lot. You're going to have to do training to people with an 8th grade or lower education, and you're going to have to talk to people in upper management if you need to get new equipment and have to justify a budget. So you're going to have to learn to communicate with a lot of different audiences, both verbally and in writing. So the better your communication skills are, the more successful you'll be in this career. And that even goes in getting your initial job. When employers come in here and interview you, they assume you have a certain degree of technical competence. Whether they hire you or not is going to be how well you communicate with them. And so communication is extremely important. And when we have our annual meetings with the advisory committee, or when I read white papers on what industrial hygienists need to know, communication skills are always listed. I'd even go a step further and say that in today's environment with a lot of multinational corporations, you would be at a competitive advantage to pick up a second language. If you can communicate in Spanish, or if you can communicate in Mandarin Chinese, particularly Spanish, you would have a very good opportunity to do industrial hygiene with an audience that a lot of our students won't. So I would strongly encourage you, if you're looking at electives, to think about perhaps picking up a second language, because that could be very beneficial in terms of your career path. Okay, that's a little bit about what is industrial hygiene. Now the next bullet point is, why do we have the field of industrial hygiene? Like most fields, we have it because there are a lot of people before us that helped make the field what it is today. And I have some contributions of important people that I'd like to go through. And this is not a comprehensive list. This is just some examples of people that have made contributions over the last couple thousand years. And they were pretty important in their own way, but again, it's not everyone who has contributed to the field of industrial hygiene. But I just have 5 that I wanted to talk a little bit about, and because of some of the unique contributions that they made. The first is Pliny the Elder. This was back at 23 to 79 AD, and he had the distinction of making the first respirator. What it was a goat bladder that he tied over the mouths of miners, because he noted that people that worked in the mines were developing health problems from what he speculated was poisonous dust and vapors, and he thought that if he could have a mask for them, that there may be a way of preventing some of these problems that they were having. So this was really an important contribution in that he recognized that some of the things that they were breathing were leading to health effects, and came up with a control method of using a bladder. It actually was a bladder of a goat that he tied over their faces to try to protect. But Pliny the Elder made the first respirator. The second person on this list, we fast forward 1,500 years almost, is Agricola. And Agricola was born at the threshold of the Renaissance, and his contribution is that he wrote the book De Re Metallica. And this was about the time when printing presses were starting, and Vasco da Gama rounded the Cape of Good Hope. And the reason that this was an important contribution, De Re Metallica, is a 9-volume treatise on mining, all aspects of mining, including health effects of mining and prevention of some of these health effects. So it was the first time in writing that diseases of miners were recognized, and some control measures were written about that could protect miners from some of the diseases that they were getting from inhalation of the toxic substances. Just as another historical footnote to this, in 1912, this 9-volume treatise of mining, De Re Metallica, was translated from Latin to the English by Herbert Hoover, who 10 years later became the President of the United States. Hoover was a geologist, by the way, and he and his wife Betty were doing geological surveys around the world, and they were on a ship for about 3 years as they went to different continents to do geological surveys. And during this time on the boat of 3 years, they spent translating the 9 volumes from Latin into English. The next person is kind of a hero to toxicologists. Paracelsus has a long name there, Philippus Theophrastus Aurelius Bombastus von Hohenheim. And he's called Paracelsus because at the time Celsius was the greatest scientist that was known, and he thought he was better than Celsius. So he was a legend in his own mind, beyond the great Celsius. He was aware of occupational diseases in miners and smelters as well. But his main contribution was this quote, and you'll find this quote in almost every toxicology book that I've ever read. In fact, I have a toxicology book in my office called The Dose Makes the Poison, Industrial Hygiene for the Toxicologist. This is a very critical quote in the study of toxicology, which we'll be talking about in 2 weeks. But it reads as follows: all substances are poisons. There is none which is not a poison. The right dose differentiates a poison and a remedy. And what this means is that anything that you're exposed to could potentially be poisonous, even water. And there was a well-publicized case a few years ago of someone who was in a contest to see how much water they could drink and not use the bathroom, and they died from water intoxication. You can overdose on water. But most substances that we know are poisonous, many of those can be used for a cure to some diseases. And so the dose is going to make the difference on whether or not something is going to be poisonous or whether it's going to be an effective treatment against certain type of diseases. This led to a dose-response relationship in toxicology. We'll talk about that in a couple of weeks, but it's a real cornerstone of the field of toxicology and the basis for most of our occupational exposure levels today, where we use a risk assessment methodology and realize that at some level, substances are going to be very dangerous, and at some level, we can be exposed to them without any adverse health effects. The next person is Bernardino Ramazzini. Kind of like that name, Ramazzini. He's the father of industrial or occupational medicine, and he's generally recognized as the compiler of the first systematic treatise on occupational diseases, which is another Latin name, De Morbis Artificium Diatriba, or Diseases of the Workers. And what he did was go through all the different professions of his time, which was in the 1700s, and look at the diseases that you would get from working in those specific professions. It's a really interesting book. I have a copy of it in my office. The Industrial Hygiene, American Industrial Hygiene Association a few years ago made a pretty inexpensive version available to all their members. I think it was about $20, but it's kind of fun to read on his descriptions of all these different types of professions that were prevalent in his time and some of the diseases that they would get if they were practitioners of that profession. The contribution that he is most known for as a result of this book is the piece of information every time you go to the doctor of having the physician say, "What do you do for a living?" as part of the medical history. And if you have ever gone and filled out a medical history form, that's one of the things they want to know. What do you do for a living? What's your job? Because there are associations between certain types of employment and certain diseases. And he's credited with getting the medical community interested to find out what people do for a living, because that could be a clue to what kind of symptoms they may be, what kind of disease they may be suffering from. Now, the last person on this list is an American, and she's a very famous American woman in the field of industrial hygiene, so much so that the United States Postal Service honored her with a 55-cent stamp a few years ago, and every year at the annual AIHA conference, an Alice Hamilton Award is presented in her honor. Again, like Ramazzini's book, the AIHA made available her autobiography, which is called Exploring the Dangerous Trades, and I actually have 2 copies of that in my office, which are kind of fun to read as well, because they talk about what life was like in the United States during her time frame and some of the dirty industries that we had and diseases that people were getting from exposure to a lot of dangerous stuff. And she really was sort of a crusader in her time frame on trying to clean up a lot of dirty industries and environmental problems that were leading to many preventable health problems. She was the first woman professor at Harvard Medical School, so she was basically a trailblazer for a lot of people. And she made the public aware of preventable occupational diseases, and until you have public awareness, you usually don't have any kind of legislation that can occur. And she's most famous for her elimination of the disease Fossey Jaw, which is a disease we no longer have because of a lot of her work. But what she did with Fossey Jaw was, this is a disease that you can get from match production, or you could back in Alice Hamilton's time frame. And matches used to use either white or yellow phosphorus. And what would happen is that if you got that into your mouth, and most people had cavities or some kind of abscesses, it could get into the jaw. And when it did that, the jaw would swell so severely that the only treatment for it was to remove the jaw. So it was a very painful, very disfiguring, horrible disease. As she talks about in her autobiography, many people that had their jaws removed committed suicide due to the disfiguration. So it was a real problem at the time. Now, I have the Etch Act mentioned, and it's kind of interesting what she did to get the Etch Act passed. Back in that time frame, the Diamond Match Company, and you probably have diamond matches around your house, came up with a substitute for the use of phosphorus in matches. It was a sulfide type of compound that you could use, and it would do the same thing for striking a match. The main difference was the cost. It was much more expensive than white or yellow phosphorus. So Alice Hamilton went to Congress and got them to pass what was called the Etch Act, which put a tax on the manufacture, production, sale of white and yellow phosphorus, so that the cost was comparable with the safer substitute. Now, about that time, due to the seriousness of phossy jaw, the Diamond Match Company decided to relinquish their patent to their competitors so that the use of phosphorus in matches just wouldn't happen anymore. So this was really kind of important because it's an example of how the public sector, i.e. the government passing legislation, the private sector, the Diamond Match Company, working within the industry to try to get rid of a problem, and the public health community making the public aware that this is something that was preventable, all working together to solve and eliminate a problem. It doesn't happen that often, but it happened in this case, and it's talked about in her autobiography. The next component of why we have the field of industrial hygiene is sometimes bad things happen and the public has a response to them. And I have a few of these that have helped in the field, and many of these are talked about in some of your safety courses as well, but they've sort of shaped and molded the field into what it is today. The first is the Massachusetts Board of Health listed, and this was because back in 1905, they were the first state to actually go and inspect workplaces. So workplace inspections started with the Massachusetts State Board of Health. The next is the Triangle Shirtwaist Fire Company. This happened in the early 1900s, and there were about 150 people that died in this fire, and this led to public outrage over working conditions and resulted in the passage of workers' compensation in many, many states. So this was sort of the beginning of the workers' compensation program. The next on the list is more specific to industrial hygiene. Harvard School of Public Health was the first academic program to begin the study of industrial hygiene, and this was back in about the 1920s, where they offered a degree through the Department of Applied Physiology on industrial hygiene. And the last on the list, I'm going to skip Gauley Bridge disaster for just a second, is the Walsh-Healy Public Contracts Act. This was passed in the Roosevelt era in the 1930s, and what this did is require anybody who had a contractual agreement with the federal government to provide a safe and healthy workplace. Now remember, back in 1930s, we didn't have an OSHA, so if a state wanted to inspect its workplaces like Massachusetts did, they were fine to. But if a state did not want to, they were not federally required to provide a safe and healthy workplace. So the feds, to address this gap, said, okay, we can't make the states at this point come up with a safe and healthy workplace because there was no OSHA. But what we can do is say, if you have a contract with us as the federal government over, I think the amount was $10,000, you have to abide by these conditions that will result in a safe and healthy workplace. The Walsh-Healy Public Contracts Act resulted from what occurred at the Gauley Bridge disaster. And I wanted to spend a couple minutes talking about this because it's really important from an occupational health perspective of a horrible tragedy that was totally preventable. I've got one of your reading assignments as an article from Professional Safety in October of 2006 that I want you to read, and I'm going to be testing you on that for examination 1. But I think it's just an outstanding article that talks about what happened at the Gauley Bridge disaster. It was the Hawks Nest Tunnel, and what happened is in West Virginia in the New River, a power company wanted to generate hydroelectric power by drilling through rock to put in a turbine. And when this construction began, the engineers noted that there was a high content of silica, so they went back and redesigned the specifications to enlarge the tunnel because silica was a marketable commodity. So it was well known that there was a lot of silica present. It was also well known at this time frame that silica was very dangerous. It was also well known that you could measure for silica and determine what levels people were exposed to. And there were techniques available at the time to minimize exposure to silica, from anything from wearing a mask, which Ramazzini had come up with, which Pliny the Elder came up with 2,000 years ago, to letting dust settle before going into a mine, to using wet drilling techniques. None of these things occurred. This was the Depression. They were under a time constraint. People could not find work, so they were coming in from all over the country because there was work done on the tunnel. Anyway, I have deaths from silicosis estimated to be 400 to 1,500. Nobody really knows how many people died from the result of exposure to silicosis on this, because if you started to get sick, somebody would come in and fill your place, and you'd go back home to Alabama or Texas or wherever you came from and die, and there'd be no record of it. But there is another book in the library called The Hawk's Nest Incident, which talks about this in quite a bit of detail, and not much more detail than a professional safety article, which goes through the A, B's, and C's of it. But that book really stresses the working conditions and what happened afterwards. At the time, workers' compensation claims had a time frame on them. They had to be filed within a certain amount of time. Since silicosis usually takes a little bit longer than the time frame to develop, the company never paid a penny to anybody for workers' compensation costs. So it was a real tragedy from that perspective. And when the public found out about this, up until 9/11, this was the largest loss of life at one workplace in the United States in history. This resulted in the passage of the Walsh-Healy Public Contracts Act, because again, we did not have a federal OSHA at that time frame, but the federal government did have the ability to require anyone who was in a contractual agreement with the federal government to provide a safe and healthy workplace. Okay, we've talked a little about what is industrial hygiene. Why do we have the field of industrial hygiene? Now let's find out what industrial hygienists actually do when they go into work at 8 in the morning and go home at 9 in the evening. How do they spend their day? And they spend a lot of their day dealing with the definition of industrial hygiene. Remember, it's devoted to the anticipation, recognition, evaluation, and control of hazards. So they spend some time anticipating hazards. And this is something that I really want to stress. If you are working as either an industrial hygienist or a safety professional, if you're having a facility that is in the process of doing remodeling or construction of a new facility, you want to take a look at the plans. Because a lot of times architects and engineers are looking at things very differently than a safety person or industrial hygienist will. And some of the problems that may ultimately arise due to design could have been prevented if a different set of eyes looked at them. So if you can, before you even start construction on something, look over plans and development of facilities, processes, and products, and fix a potential problem at that point, it's going to be much less costly to fix it there than to fix it later. Unfortunately, this doesn't always happen, but if you have an opportunity to get involved in it, be sure you do. Be sure you do that. What typically happens, though, is industrial hygienists spend more time on the recognition, evaluation, and control. And recognition is just acknowledging that health hazards are present in the workplace and they happen in existing operations. And you'll go about and you'll try to collect information on what some of these hazards are. You'll look at what the inventory of hazards are. If it's chemicals, you can look at the material safety data sheets. You can do job analysis, things like that, to get an information of what some basic background on what kind of hazards are actually present within that workplace. Then the next step is evaluating those hazards. An evaluation is defined as examining an operation to determine the extent of the health hazards present. And what you do to do this examination is you do measurements. And measurements will help you know the magnitude and significance of whatever that hazards may be. So if it's noise, you'll go out and you'll do some noise monitoring. And if it's chemicals, you go out and measure the chemicals. So this is something that especially introductory industrial hygienists will spend a lot of their time doing to try to, they know that the hazard's present, so they go out and evaluate it. They'll monitor for noise, they'll monitor for benzene, they'll monitor for aerosols, and this takes up a large chunk of their time on the evaluation part. And the last part of what industrial hygienists will do is control a hazard. And control is defined as the adjustment or regulation of an operation to meet a hazard. And this can be done by reducing and preventing a contaminant to be released, containing it, the hazard, so that it's no one will have exposure to it. And controls are usually done in a hierarchical approach where you prioritize which controls to use first. You can use engineering controls, administrative controls, and personal protective equipment. And of those three, you want to first apply engineering controls. And what engineering controls are they're a way of controlling the problem by either a process change, substitute to a less hazardous chemical or exposure, eliminate the exposure if possible, ventilation changes can drop the contaminant concentrations pretty significantly. So if you can control a hazard by engineering, that's the way to do it. It's not always done because sometimes engineering can be very, very expensive, but ideally this is a way of actually eliminating the hazard by substitution or ventilating it out or something, changing the process. The next type of control is administrative control, and this requires some management involvement where you'll be needing some training, job rotation, making sure that people that are exposed, you can reduce their exposure time, preventative maintenance if possible, or housekeeping. And housekeeping, an example of that is if you're dealing with an aerosol like a hexavalent chromium or beryllium or lead or something like that, clean it up at the end of the work shift, because if the dust settles out, then you have the potential for disturbing that dust and have a subsequent exposure. So housekeeping can be really important on controlling for a hazard. And the last thing that you ever want to do is personal protective equipment. And it's the last thing because the hazard's still there, and now you're relying on a person to use a piece of equipment to protect them against the hazard. You're relying on them to use a respirator or gloves or eye protection or ear plugs or ear muffs or something to protect them against the hazard when the hazard is still there. So you're relying on the person, A, to use it properly, and B, for the equipment to be functioning properly. And if you can prevent the reliance on those two variables, you're much better off. You're much better to get rid of the hazard through engineering controls or administrative controls. But if you can't, then go with the personal protective equipment route, but realize that the hazard is still there, and now you're relying on a piece of equipment to protect someone against that hazard. The last thing on this list of what industrial hygienists do is belong to professional organizations. And I have the two major professional organizations there, as well as the accreditation agency. The major organizations are AIHA and ACGIH. AIHA is the American Industrial Hygiene Association, and ACGIH is the American Conference of Governmental Industrial Hygienists. And the first one is the largest industrial hygiene association. It has, I think, about 15,000 members. And the second one is the oldest industrial hygiene association, which was founded first. And this is composed of people who are government employees. And by government, could be federal, could be state, could be municipalities. But its membership is restricted to people who have who are employed by the government, whereas AIHA is basically anybody involved in the practice of industrial hygiene. The last on the list is ABIH. And you noted on my first slide I had an acronym behind my name called CIH. This stands for Certified Industrial Hygienist. And to become a certified industrial hygienist, you have to go through the American Board of Industrial Hygiene because they are the certification agency. And to get your certification, it's a process which involves examination, a certain background to sit for the examination, an educational background showing that you've met certain course criteria, a work experience background showing that you've done some work in industrial hygiene, and then you sit for an exam, and the exam is about a 40% pass rate, so it's a pretty difficult examination. And then once you get that, you have a 5-year cycle where you have to maintain active practice of industrial hygiene to continue keeping your certification. And this is something we'll talk about more throughout the semester, but that's the industrial hygiene side of the certification. Those of you that are more familiar with safety, the Board of Certified Safety Professionals is the agency that will give all of you, when you graduate, your GSP certification. And if you want to continue the practice of safety, your Certified Safety Professional, your CSP, a little later on in your career. Okay, the last thing is really an examination of some of the recent changes that have occurred in the field of industrial hygiene. And I have 5 things listed here. These aren't the only 5. I'm a member of the American Industrial Hygiene Association, and as such, I get a little monthly magazine called The Synergist. And I read it because what it does is tell me what's going on in the field of industrial hygiene. And there are some topics that come up, and these are topics that have come up over the past 2 years on some changes that are occurring in the industrial hygiene field. And this is some things to talk about. These aren't the only ones, but they are some important new developments that are occurring. And I have them listed here as globalization, nanotechnology, ethics, molecular biology or toxicogenomics, and occupational exposure limits. Globalization is real important. This year, OSHA has promulgated a new GSH standard, which stands for a Globally Harmonized System of Classification and Labeling of Chemicals. What that means is that every MSDS in any company in the United States is going to be obsolete as of December, and it's going to change to, I think it's called an MDS, Material Data Sheet, that is in sync with what's going on in the rest of the world. So there is a real push to have a system of labeling that is consistent from one country to the other, and OSHA has a new standard just this year, which is going to affect all of us on this harmonization type of an approach. And another globalization outreach, which is important for industrial hygienists to know, is REACH. This is the European Union's approach to the regulation of chemicals. It's an acronym that stands for Registration, Evaluation, Authorization, and Restriction of Chemical Substances. But we have, in this country, our permissible exposure limits by OSHA, but they have a different approach in Europe on ways of setting standards and handling for different chemicals. And it's important to understand these different types of approaches that are used internationally, especially if you're dealing with companies that are going to be going across borders. And that brings the last point on the list, is that we've gotten rid of a lot of the occupational health issues that Alice Hamilton observed back during her lifetime. But they still exist in the world. And if you go and work in international companies, you're going to find occupational health issues that we don't have here, and you need to be aware of those as the companies become more and more global. The second bullet point is nanotechnology, and this has become an area where NIOSH has really put a focus on over the past couple of years. Nanoparticles are those that are defined as 0.1 micron or below. If you attend many of the info sessions that companies will be coming in this spring to talk to you about, you'll hear that many of them are dealing with nano processes. And so this is going to become something that you're going to be probably dealing with throughout the course of your career. And currently, we don't really have a lot of information or a lot of regulations on how to address nanotechnology. It's very unclear what health risks they do present, and therefore we don't know exactly how to set standards to protect against them. I've got a journal article listed here. A couple of years ago, we had a student in this program that published a paper that he'd written for one of my classes on nanoparticles, and it's in the Journal of Chemical Health and Safety. And it just addresses some issues. I know this is a couple of years old, but they're still relevant today, and NIOSH is still struggling with what exactly to do with nanotechnology, and doing some active research on trying to understand exactly what problems are arising from exposure to these particulate matters that are that small. The next bullet point is ethics. I just recertified in my CIH last year, and I had to get ethics training. They're requiring that the American Board of Industrial Hygiene is requiring that all industrial hygienists undergo ethics training when they recertify their cycles. So it's becoming really important for the certification agencies that the membership are trained in ethics, due to trying to eliminate any potential ethical problems that their members may get. So if you get a CIH, you're going to be taking ethics training. The next one is molecular biology and toxicogenomics. And when I took toxicology and got my degree in it back in the 1980s, this wasn't really all that big of a field. It's really exploded since then. And the reason that it's exploded is, I've got a couple examples here. For example, beryllium. Beryllium can lead to an occupational disease called chronic beryllium disease, which is a disease where your lungs will fill up with these inflammatory masses, and you slowly suffocate. And all the physicians can do is provide supportive treatments. You're going to basically slowly die from lack of oxygen or suffocation. The reason that I have this on the list is back in the 1990s, molecular biologists were studying beryllium disease and noted that people who developed chronic beryllium disease had a specific gene marker, and those that did not develop chronic beryllium disease did not have this marker. So they were able to identify a gene that made people susceptible to the toxicological effects of beryllium. Subsequent to that, that's become true with many carcinogens that we've studied. I had a list of a couple of carcinogens early: benzene, vinyl chloride, hexavalent chromium. If you look at people that are exposed to benzene, for example, you'll note that thousands of people are exposed, and yet only a few dozen have developed cancer. What's different about these people? Well, as we study carcinogens more, we're understanding that there are genetic markers that make people more susceptible to developing cancer through a chemical exposure than other people. So the question becomes, what do you do with this information? If you know that somebody that's going to be working around beryllium has this gene marker, what do? You tell them you can't have this job? Well, that would be discrimination. So how do you protect the workforce properly, knowing that some people are going to be more susceptible to the effects of chemicals than others? And no one really has an answer to this question. And I think it's something that, as an industrial hygienist throughout your careers, you'll have to ponder how to best utilize the information we have to protect the people that are going to be having these exposures. And the last bullet point is occupational exposure limits. And we'll be talking about this over the next couple of weeks quite a bit when we get into toxicology and occupational exposure limits. If you want to use a chemical in commerce in the United States, you have to register it. And currently the registration list is about 85,000 chemicals that are used in commerce in the U.S. If you look at, since OSHA's inception, how many chemicals it's actually put a PEL on, it's about 30. And it adopted from ACGIH about 500, and ACGIH has some more, as well as NIOSH. So if you look at all the chemicals that we have some kind of a recommendation on what the level should be, it may be 1,000. And that's a whole lot less than 85,000. And this is a big problem. This is recognized by the current director of OSHA, David Michaels, on what do you do about this? No one really has a good answer for it, but it's got a lot of people right now in the occupational health community trying to come up with a better way of developing occupational exposure limits than what we have currently. But anyway, those are just a few of the current developments. They're not all of the current developments, but some things that are changing in the field. And that concludes my discussion of an overview of industrial hygiene. And if you have any questions, just feel free to ask me or shoot me an email. Thanks.